हॉलोस्फीयर कर लिया था ना हमने, सेंटर ऑफ मास ऑफ हॉलोस्फीयर। आवाज आ रही है मेरी? Everybody can hear me. So this is the last standard center of mass that you have to remember. Beyond this, whatever question I give, you don't have to remember it, but you do have to, but you will have to find out the center of mass of various objects. So center of mass of a solid hemisphere So we already know the center of mass of a hollow hemisphere. So I know that the solid hemisphere is made up of infinite number of I'm sorry about my drawing. So the solid hemisphere is made up of infinite number of hollow hemispheres of increasing radii, out of which I choose one. Okay. बहुत ही ज़्यादा गंदा हो गया। Out of which I choose one, like so. This is the it has a slight thickness, and the radius of this is, let's say, r, and the thickness is. So y coordinate of center of mass is equal to integral of y dm divided by integral of dm, where y is equal to the y coordinate of the center of mass of the chosen element. In this case, it is the blue hemispherical shell. Okay. So this will be equal to integral of क्या होता है hemispherical shell का center of mass का location. What is the location of? Please tell me. हमने किया था ना last class में ये? हाँ, very good. So radius upon 2, right? Radius upon 2. So इसका radius है small r upon 2 into rho, that is the volume mass density, because we are dealing with a solid object, multiplied by the volume of the blue hemisphere. So dV will be equal to surface area multiplied by thickness, which will be equal to 2 pi r square multiplied by thickness, which is dr. So 2 pi r square. Okay. Divided by dn, which is just a replica of the above 2 pi r square. Before I carry out the integration, I must decide on the limits, and I see that the smallest hemisphere that will make, or that is part of this, that will make this solid hemisphere is this, and the largest one, of course, largest hemispherical shell is this. So the limits will go from 0 to R, 0 to R, right? And now physics is over. So the maths, यहाँ पे क्या क्या कॉमन आ जाएगा, by 2 कैंसिल हो जाएगा, pi rho will come out, pi rho integral of r cube dr 0 to r divided by 2 pi rho integral of r square dr 0 to r. Pi rho will cancel out. This will be equal to 1 upon 2 into r power 4 by 4 divided by r cube by 3, which is equal to, which is equal to which is equal to 3r upon 8. Right? So y coordinate of center of mass is equal to 3r upon 8. And always remember that my origin is here, right? Don't forget that, please. My origin is at the center of the. Please write this down. Please write this down. Yes, you need to remember. Yes. Okay, so let's object and center of mass. हमने क्या क्या देखा अभी तक? हमने देखा half ring, center of mass is equal to 2r by pi. Half disk, center of mass is equal to 3r by 4 pi. Hemispherical shell, center of mass equal to r by 2. Solid hemisphere, center of mass equal to 3r by 2. Okay, so these are things you have to remember. Please write this down quickly, so I'll move ahead. now that we have discussed the techniques, it is expected that you should be able to find the center of mass of objects, whether they are uniform or non-uniform. Okay? So first, let's try a non-uniform object. So we have हाँ, तो ये रिजल्ट्स तो याद रखने ही हैं, राइट? बट इसका जो डेरिवेशन है ये भी हाँ, hemispherical shell and hollow hemisphere are the same, yes. So the derivation plays a very important role. Question number 1. A rod of length L has linear density given by lambda is equal to lambda naught x square, where x is distance from one end as shown. Find center of mass. Sure. Now use all the techniques that we have discussed. Very good. So I will chop this into pieces. नहीं भाई यूनिफॉर्म कहाँ है इसमें? जब उसकी लीनियर डेंसिटी वेरी कर रही है तो यूनिफॉर्म कहाँ है? आपको क्या मतलब समझ में आता है यूनिफॉर्म का? So I will choose this. I will choose this dx x coordinate of center of mass is equal to integral of x dm divided by integral dm, which is equal to integral x, जो सिंपली इसका x coordinate है, multiplied by dm, which is lambda dx divided by lambda dx, which is equal to, now I can put in the value of lambda and I'll get lambda naught x cube dx divided by lambda naught x square dx, and the integration will be carried out from 0 to L, 0 to L. So this will be equal to lambda naught cancel हो जाएगा. This will be equal to L power 4 by 4 divided by L power 3 by 3. So the x coordinate of center of mass is equal to 3L by 4. ठीक है? With uniformity, non-uniformity समझ में आई कि नहीं? अगर मैंने ये दे दिया इसका मतलब नॉन यूनिफॉर्म, इसका मतलब क्या है? इसका मतलब ये है कि जब मैं यहाँ पे हूँ और जब मैं यहाँ पे हूँ तो रॉड की डेंसिटी डिफरेंट है, राइट? इसका मतलब कि ये स्लाइस का मास और ये स्लाइस का मास डिफरेंट होंगे, and that is non-uniformity. Right? So masses of these two slices will be different. हाँ ठीक है, मैं और भी लोग हैं. वॉल्यूम तो कांस्टेंट रहेगा ना. हाँ वॉल्यूम कांस्टेंट, वॉल्यूम से क्या लेना? लैम्डा डीएक्स ही तो मास होता है भैया. थर क्या हो गया तेरे को? पहला प्रूफ देखिए जो मैंने करवाया था लास्ट क्लास में, 3 तरीके की डेंसिटीज बताई थी. देखिए और देखो कॉपी. मत भूलो भैया, मेरे को डर लगता है. चलो नेक्स्ट. So in the last question, you could take a point particle as the element. Okay. हाँ मैं अरेंज कराता हूँ ना. वो अमन सर बोलते हैं ना जब ग्रुप में डालते हैं ना, सेंटर में चले जाओ. So in the last question, you took the point particle as the element, right? But that will not always be the case. Find center of mass of cone of height h, radius. सॉलिड सॉलिड जब तक मैं नहीं बोलूंगा हॉलो तब तक सॉलिड अज्यूम किया जाए. सॉलिड हाँ बिल्कुल सही. I'm going to change the slide and give the next question as well. Find the center of mass सॉल्व करना है, मेमोराइज नहीं करना है. Find center of mass of a solid of revolution of curve y is equal to x cubed from x is equal to 0, x is equal to, जिसको समझ में आ रहा है वो करो, जिसको नहीं समझ में आ रहा है प्लीज आस्क. You have to find the center of mass of this cone and this. Let me explain to you. Let me explain to you the meaning of this. I don't think समझ में आ रहा है कई लोगों को. So, what is meant by solid of revolution? So, if I have this straight line like this, okay, since we are doing it about the x-axis, if I have a straight line like this, okay, यहाँ पे actually I should mention also solid of revolution of curve about x-axis. So if we have this straight line and I say that find the solid of revolution of the straight line about the x-axis, then what you're going to do is you are going to revolve this straight line about the x-axis, and whatever shape the revolution will chart out will be the surface of the solid. So this straight line is, when revolved, is going to give us a cone. Okay? So the solid of revolution of a straight line is a cone. Right? So basically what is happening is that this blue line is made to rotate about the x-axis, and whatever paths it sweeps out is considered to be a solid. So in this case, when this curve is revolved about the x-axis, then it will create a solid of revolution like this. A cone, conical shape, but with a curved, not a straight cross section. Hey, ready? Okay, sure. I'll show you again. So what you have to do is remember the technique. That's it. So how do I construct a solid cone? Mathematically, of course. How do I construct a solid cone? Any ideas? How do I construct a solid cone? Very good, Abhijit. Yes, exactly. Yes. Anybody else? How do I construct a solid cone? How will you practically construct a solid cone? एक सॉलिड कोन को कंस्ट्रक्ट करने के लिए हमें क्या करना चाहिए? ट्रायंगल प्लस सर्कल क्या बोल रहा है जोहेब यार? कार्विंग सिलेंडर लो, नहीं, स्फीयर डिस्क, हाँ डिस्क से बनाएंगे ना कोन को. So what you will do is that you will place discs on top of each other, just like we did for a solid, just like we did for a hollow sphere. And these discs would be decreasing in radius, right? Ultimately, if you place the discs correctly, you will get a cone. That is how you construct a cone. So now what I want to do is I want to find out where the center of mass of the solid cone is, and to do that, I will not choose my origin at the bottom. I will choose my origin at the top. So I will say that look, from here at a distance of y, there is a disk which is my element. Okay? अब अर्जुन की तरह हमको केवल ये रेड डिस्क दिखाई देगी, केवल ये रेड डिस्क दिखाई देगी. इस रेड डिस्क का सेंटर ऑफ मास कहाँ होगा और इस रेड डिस्क का मास क्या होगा? So this is y dm divided by integral dm, where y is the y coordinate of center of mass of the chosen element. In this case, it is the red disk. Okay, so a cone is made up of disks. Now, इससे पहले आपको ये मालूम था, नहीं मालूम था, maybe you worked it out, maybe you did not work it out. It does not matter, because from now on, you are going to remember that a solid cone is made up of solid disks. Now you may think, अरे अरे एक मिनट, ये सबके लिए याद करना पड़ेगा क्या कि क्या एलिमेंट होता है? And the answer is that I will, within the theory and within the questions that we discuss in class, I will take care of all the possible elements. Once my lecture is finished, once our discussion is finished on finding center of mass, right, then be rest assured कि जो हमने डिस्कस किया है उसके अलावा कोई एलिमेंट पॉसिबल नहीं रहेगा. ओके, ठीक है? तो आफ्टर द थिंग इज ओवर, देन यू शुड हैव नो confusion, or there cannot be an object for which there will be a new kind of element. ठीक है ना? एक बार फिर से इसके लिए देख लेते हैं यहाँ पे क्या था, एलिमेंट क्या था. इसके लिए at an angle of theta, d theta, right? This was the element. The element was a point particle. For a half disk at a radius of r, we had a half ring as the element, right? For the hemispherical shell at an angle of theta, right? D theta width ka, we had a ring, full ring, like this. So this was the element. This was the element for a hemispherical shell. For a solid hemisphere, the element was a hollow hemisphere of radius r and thickness dr. Can you take disks as an element for a hollow sphere, for a solid sphere? Yes, you can, and I'll show it to you. So you can say that this hollow sphere, solid sphere is made up of disks. So, no problem whatsoever. This is the location of the element will be y from the center of the solid hemisphere, and therefore the thickness will be dy. Okay. So by using this technique, yeah, rings or disks stacked upon each other, you can construct a hollow sphere, you can construct a solid sphere, you can construct a hollow cone, you can construct a solid cone. Okay. Okay. Once you have gotten hold of, अच्छा चलो इससे पहले, for those of you who want to do, what do you think will be the element here? What will be the element here? What will be the element here? बताओ भाई, कोई तो बताओ, what will be the element here? Exactly. Yes, अभिजीत. और अभिजीत के अलावा और कोई नहीं? विश्वजीत. अगर कभी भी कंफ्यूजन हो, अगर आपके मन में अभी भी एलिमेंट के लिए कंफ्यूजन हो रहा है, जो कि नहीं होना चाहिए, अगर कभी भी कंफ्यूजन हो, राइट, देयर आर टू थिंग्स टू थिंक. केवल दो चीजें हैं सोचने के लिए. एक वो मार्बल वाली कहानी. मार्बल वाली कहानी क्या है? मार्बल के ऊपर पेंट किया, फिर सूखने के लिए छोड़ दिया, फिर एक और पेंट किया, फिर सूखने के लिए छोड़ दिया. ठीक है. एक वो मार्बल वाली कहानी और एक वो तलवार वाली कहानी. यहाँ पे तलवार लेके आप सब कुछ काट पीट दो. So would you, if you do in your head, if you do this in your head, या आपके सामने, in front of you you have this object, right? You have this solid object. अब अगर आपने इसको तलवार से काटना शुरू किया, okay, ऑप्शन नंबर 1. ऑप्शन नंबर 2, आपने इसको, वो जो जैसे मैंने सॉलिड स्फीयर को ग्रो किया था लेयर बाय लेयर ऑफ पेंट से, which option do you think will be better here? अगर हम इसको तलवार से काट देंगे तो मेरे को क्या मिलेगा? What will I get? And I'm not saying that we तलवार लेके आप रैंडमली उसको काटना शुरू कर देंगे, थोड़ा सा तरीके से. अगर तलवार से अगर हम इसको स्वॉर्ड से इसको हम काटेंगे, what do we get? And can we grow this thing by painting layer upon layer upon layer upon layer upon something? बताओ, सोचो, think, tell me. Anyone? हाँ सोनल, yes. I mean 50-50 चांस थी, गलत हो गया तो. See, I mean, what will you paint? So if you want a solid hemisphere, you can paint a sphere and then cut it in half. Okay, and if you want a sphere, then you have a marble and you keep on painting on it, and you keep on getting a bigger and bigger sphere. But यहाँ पे, where do you start with? What do you paint on? Okay, what do you paint on? क्या आप शुरुआत में ऑब्जेक्ट लेके शुरू करोगे जिसमें पेंट करोगे? No, you cannot. This has to be cut. This has to be cut. So if I were to make cuts by a sword like this, what is the object that I would retrieve in between these two cuts, in between two adjacent cuts? What is the object that I will retrieve? What is this? What is this? ये क्या चीज है? ये जो मैंने ब्लैक से ड्रॉ किया है, ये क्या चीज? अभिन, क्या चीज है ये? बेटा रेक्टेंगल नहीं, 3 डायमेंशन में है बच्चा. कोन को अगर आप ऐसे काटोगे तो आपको रेक्टेंगल मिलेगा क्या? हाँ, लोग बिल्कुल सही. क्यूबॉइड. रिंग नहीं, सॉलिड है अभिन. सॉलिड को काटने पे रिंग नहीं मिलता है. बकेट से बाल्टी मिल जाएगी धनुष तेरे को यहाँ पे? क्या बोल रहा है? कौन काटने पे बाल्टी मिल जाएगी? नहीं. Let me show you to again. हाँ, ट्रेपेजियम मिलेगा, but trapezium type, I understand what you are saying. हाँ, frustum type, but since it is very, very thin, extremely thin, therefore it will look like. So this is the object that we have. This is the object that we have. This is a solid object like this. So if I were to cut an extremely thin slice out of this object, if I were to cut this extremely thin slice out of this object, I would end up looking at it from the top. I would end up something like this. हाँ, नहीं फ्रस्टम बिल्कुल सही बोला, फ्रस्टम बिल्कुल सही बोला है फ्रस्टम. But since it will be so thin, it will be so thin that for all practical purposes you can treat it like a disc, because dealing with frustums is very difficult. Dealing with discs is very easy, because ultimately, remember, you want to find the volume, and the volume of a disc is simply equal to area multiplied by thickness, right? And I don't even want to talk about the volume of a frustum. No, I don't. The power of calculus lies in the fact that we can make these assumptions. Sometimes, of course, these assumptions may go wrong, but 99% of the time there is no problem. Okay, so I hope समझ में आया है. So we get y coordinate is minus y. Okay, I'm just taking the downward direction as minus. I can take it plus, कोई फर्क नहीं पड़ता. Into dm, which will be density into the volume of the red disk. Density into the volume of the red disk. Any idea how to find the volume of the red disk? The thickness of the red disk is given by dy. ये भी फ्रस्टम ही रहेगा. Okay, ये भी फ्रस्टम ही रहेगा, लेकिन ये dy is so small. Remember the term dy and dx I introduced in calculus at the beginning, and the meaning of dx and dy was infinitesimally small. Right? So here also we carry over that meaning. It is infinitesimally small. We can just use the circumference. Yes. So 2 pi y square dy. नहीं. Y is not the radius. Yes. अभिजीत निकालना पड़ेगा रेडियस. आपको ये डिस्क का रेडियस नहीं मालूम है, आपको केवल ये मालूम है कि ये डिस्क की लोकेशन, डिस्क के सेंटर की लोकेशन एपेक्स से y डिस्टेंस नीचे है. तभी तो यहाँ पे ये लिया ना मैंने, ये जो हमने यहाँ पे लिखा है y coordinate of center of mass of chosen element, in this case the red disk. This is what I've written here, because for a disk the center of mass is at the center, right? Very good, Dhanush. Yes. और कोई तरीका? सिमिलैरिटी तो बोल दिया अभिजीत ने और धनुष ने. और कोई तरीका? Any other तरीका you can think of? Well, it is actually similarity, but I will go about it in a different manner. I will say that this is angle theta, and if this is angle theta, then this radius then becomes y tan theta. Okay, because tan theta is equal to opposite over adjacent. Adjacent is y, so I get y tan theta. Okay, and remember that tan theta is nothing but r upon h. Right, so I am actually using similarity only, but with trigonometry. So density into pi r square, that is pi y square tan square theta, into thickness, which is dy, whole divided by integral of density into pi y square tan square theta dy. Okay, now we need the limits. And for the limits, I will choose the discs that make up this cone, which exist at the extremes of the cone. So this guy exists here, which I'm drawing, but I don't think you can see. This guy exists here. and the other extreme guy exists here. So what is the value of y for the guy located at the apex, and what is the value of y for the red disk located at the bottom of the cone? Well, y is the distance from the apex, so anything at the apex must have a y value of 0, and the bottommost disk is at a distance of h from the so you can either use minus h or h, does not matter. We are just trying to find the location of the center of mass. So y is equal to क्या क्या बाहर आ जाएगा, rho pi tan square theta. Remember tan theta is a constant, minus integration of y cube dy, integration of y cube dy from 0 to h, whole divided by rho pi tan square theta, integration of y square dy, okay, 0 to h. These two guys, they cancel out, very nice for me. And the integration gives me h power 4 by 4 divided by h power cube by 3. So the y coordinate is going to be 3h by 4. That means that y coordinate of center of mass is 3h by 4 from the apex, or h by 4 uh, from apex, or h by 4 from bottom. वो h by 3 जो बताया था जो है, that was for a hollow cone, okay? Not for a solid cone. That was for a hollow cone. Right? Any step which is unclear in any way, please ask. Any step which is unclear in any way, please ask. DM. DM is density into area into thickness, and this area is equal to pi r square. R is equal to y tan theta. Why always y CM? Because x CM हमेशा 0 है, हमें मालूम है. लेकिन यहाँ पे here you have to find x CM. यहाँ पे y CM 0, because this object, remember, is any symmetry is there about the x-axis, y coordinate of center of mass will be 0. any symmetry is there about the y-axis, the x-coordinate of center of mass will be 0. So this object has symmetry about the x-axis, so y-coordinate of center of mass is 0. And this object has symmetry about the y-axis, therefore. तो इसलिए कभी कंफ्यूज मत करना, मैं YCM करते जा रहा हूँ, मैं यहाँ पे YCM लिखते जा रहा हूँ, लेकिन ये जरूरी नहीं है ना। अगर मैंने ये हाफ रिंग को ऐसे ले लिया तो यहाँ पे आएगा सेंटर ऑफ मास। अगर मैंने ये हाफ डिस्क को ऐसे ले लिया तो यहाँ पे आएगा, राइट। अगर मैंने ये हेमिस्फीयर को ऐसे ले लिया तो यहाँ पे आएगा, एंड सो ऑन. So it is just for the purpose of drawing that maybe I have taken whiteboard. Okay. So if this is understood, then please try to give a serious attempt for this. I'll give you 2 minutes. I'll give you 5 minutes. So, very nice. नहीं 4 तो नहीं आया. I don't think so. Does it have किसी ये x है, ये dx है. So the x coordinate of center of mass will be given by integral x dm divided by integral dm will be equal to इंटीग्रल ये डिस्क, ये जो ब्लैक डिस्क बनाई है इसका एक्स कोऑर्डिनेट ऑफ सेंटर ऑफ मास एक्स ही है क्योंकि डिस्क का सेंटर ऑफ मास सेंटर पर रहता है इनटू डेंसिटी इनटू पाई रेडियस स्क्वायर इनटू थिकनेस डिवाइडेड बाय इंटीग्रल ऑफ रो इनटू पाई इनटू रेडियस स्क्वायर divided by thickness. I need to work out two things. One is the radius of the disk, and the other is and the other is limits. Okay, so यहाँ से आप करिए. Do this. Work out the radius of the black disk. Work out the limits. Well, the limits are actually given in the question anyway. क्या हो गया तेरे को? ये सॉलिड ऑब्जेक्ट है या हॉलो ऑब्जेक्ट है? ये सॉलिड ऑब्जेक्ट है या हॉलो ऑब्जेक्ट? सॉलिड में हमेशा रो लेके चलेंगे ना. नहीं, tan थीटा नहीं आएगा. x नहीं आएगा ना राधिका आंसर में. दैट वुड बी रेडियस. पहले बताओ मेरे को रेडियस क्या है. व्हाट इज द रेडियस? व्हाट इज द रेडियस ऑफ द डिस्क? वेरी गुड. यस अभिजीत. tan थीटा नहीं आएगा ना. वेयर इज why is it tan theta? What do you think is the meaning of this? इसका क्या मतलब है? इसका मतलब ये होता है that if I am at x equal to 1, then on the curve y will be equal to 1. X equal to 2, on the curve y will be equal to 8. So if I am at a distance of x, then y coordinate will be equal to, which is the radius, will be equal to x cube. Right? Right. So taking out the constants, I will get limits also first. ये x कहाँ से कहाँ तक वेरी करेगा? यहाँ से ये पहला वो डिस्क है यहाँ तक, ये आखिरी डिस्क. So this will go from 0 to 5. 0 to 5. So this will be rho pi cancel हो जाएगा because they are constants. They will come out of the integral, and I will get integral of x raised to the power 7 dx divided by integral of x raised to the power 6 dx. 0 to 5. 0 to 5. This is equal to x raised to the power 8 by 8 divided by x raised to the power 7 by 7. 0 to 5. This is equal to 7x by 8, 0 to 5, which is equal to 35 by 8 units. So the center of mass of this object is at 35 by 8. ये हर क्वेश्चन क्या है? Find the center of mass of a solid of revolution of the curve y is equal to x cube. Y is equal to x cube. कर्व मतलब क्या होता है? y is equal to x cube का कर्व बनाने का मतलब क्या? कौन से पॉइंट्स प्लॉट कर रहे हैं हम? बताओ था, कौन से पॉइंट्स प्लॉट कर रहे हैं? x इक्वल टू 0 पे y इज इक्वल टू क्या होएगा? x इक्वल टू 0 पे y इक्वल टू 0. x इक्वल टू 1 पे y इक्वल टू क्या होएगा? x इक्वल टू 2 पे y इक्वल टू क्या होएगा? x इक्वल टू 3 पे y इक्वल टू क्या होएगा? x इक्वल टू x पे y इक्वल टू क्या होगा? y क्यूब नहीं, x क्यूब. Okay, so once again, if I give you find the center of mass of a hollow cone, okay, then this hollow cone will be made up of rings, out of which I choose one ring here. Now, whenever there is a hollow cone, you must always choose the variable like this, not straight वाला variable. Solid cone में straight वाला variable, hollow cone में ऐसे वाला variable. So if this angle is theta and this is r, then what will be the radius of this circle? What will be the radius of the circle? So sine theta is equal to radius of the circle divided by r. Uh, so radius is equal to r sine theta. Y coordinate of center of mass will be equal to integral minus y. Now since it's a hollow cone, we'll have to use sigma. Hollow matlab sigma into the area of the ring that I have chosen. This will be equal to circumference, which will be 2 pi r sine theta, into thickness, which is dr, divided by sigma into 2 pi r sine theta dr. Okay? And what does the limits, where does the limits go from? Goes from 0 to under root of h square plus r square. Okay? Please don't be surprised because हमने जो वेरिएबल लिया है वो ये साइड लिया है. ये साइड का जो पूरा लेंथ है, दिस इज रूट ऑफ आर स्क्वायर प्लस एक्स स्क्वायर. So then this will sigma 2 pi sine theta, sigma 2 pi sine theta will cancel out, and I will get, now I don't want to write minus y here. Okay, I don't want to write minus y here because दूसरा वेरिएबल आ जाएगा. This is the distance, right? This is the distance. So minus y will be written as minus r cosine theta. Let me just rub this out. ऐसे ही मतलब does not have to be minus. I am choosing the xy coordinates here. I am measuring everything from the apex. So you can choose positive, no problems. In fact, okay, I'll take it as positive. So this will be r cosine theta. So end up with cosine theta integral of r square dr divided by integral of r dr. Cosine theta r square का इंटीग्रेशन r cube by 3 divided by r square by 2. This is equal to cosine theta into into 2r by 3 from 0 to root of h square plus r square, which is equal to cosine theta की क्या वैल्यू होगी? h divided by root of h square plus r square is cosine theta into 2 root h square plus r square by 3 when I put in the limits. So this guy and this guy cancel out. We get y cum is equal to 2h by 3 from apex. This will be equal to h by 3 from bottom. ठीक है? Okay. Slide number 1, please take a screenshot. We calculated the center of mass of a solid hemisphere. A solid hemisphere is made up of, either you can choose discs or, which I find better, solid hemisphere is simply made up of hollow hemispheres. Please take a screenshot. Then for various objects, we have found the center of mass. Now these four values have to be unfortunately remembered because you will understand. Okay, I hope that you are already beginning to understand that after 6 months, there is no way that you are going to remember all this mathematics, the proof. उसके लिए तो आपको फिर से revision करना ही पड़ेगा. Right, and when we do revision, I will derive everything again, and by that time you would have had so much of similar derivation that hopefully things will become absolutely crystal clear. But since you are not going to remember the derivation uh, just before the test, you should revise the derivation. But these four values you should remember, because in any test you are not going to really derive 2r by pi or 3r by 4 pi. And these values will have direct appearance on the in the question. हाँ, हाइपोटेन्यूज है ना राधिका. मैंने वेरिएबल क्या लिया है? वेरिएबल कहाँ है मेरा? वेरिएबल क्या लिया है मैंने? नहीं, एक एक करके आंसर करते हैं ना. वेरिएबल क्या लिया है मैंने? वेरिएबल तो ये लिया है ना. तो लिमिट्स तो यहाँ से यहाँ तक होएगा ना. हाँ, मैं सारे स्लाइड दिखा रहा हूँ. ये पूरी लेंथ कितनी है? हाँ. So these four things you have to really keep in mind. Okay? Then we saw how to deal with objects which are non-uniform. There is no difference in dealing with non-uniform objects. All you have to do is carry out the integration properly. For linear objects, whether they are in a straight line or whether they are in circle, remember that the element is a point object. Okay? For these guys, I have showed you the elements. Point object है, ऊपर वाले का element. यहाँ पे point object है, यहाँ पे half ring है, यहाँ पे full ring है, यहाँ पे hemisphere, hollow hemisphere. So here the element is a point object. Please take a screenshot. Then we found the center of mass of a solid cone, and finding the center of mass of solid cone is all about, or finding the center of mass of any object is all about choosing the element, which you can get either by mentally slicing the object by a sword into thin slices, or you can think of the marble wala story where the object may be made of something built on top of each other. Now here this is a solid cone, so if you think that solid cone is built on top of each other, then no, that won't be possible, because the apex wala point ना उसको थोड़ा सा गड़बड़ कर देता है. So solid cone has to be built out of discs. Okay, then I showed you this is how a solid hemisphere is made out of discs. If you were to do solid hemisphere, then solid hemisphere using discs, this would be the way to do it. Then we found the center of mass of this weird thing, solid of revolution. This is something that may appear in a test paper. Not very difficult thing to grasp. Solid of revolution of anything really is that you take that line and you revolve it around a particular axis, और जहां जहां वो revolve हो रहा है, जो भी sweep out कर रहा है वो, that becomes a solid. Okay? So for example, I showed you that the solid of revolution of a straight line is a cone. Please take a screenshot. So this is another way of looking at this. This is another way of looking at this object. Okay. हाँ, equation given होएगा ना, नहीं तो फिर नहीं कर पाएंगे. And then finally we figured out the center of mass of a hollow cone. Now hollow cone I had to do specially for you because the variable that you have to introduce to identify the ring which makes up the hollow cone is very special. यहाँ पे हम vertical वाला distance नहीं लेते हैं, यहाँ पे हम along the conical surface वाला distance लेते हैं. Okay, so this you have to remember for a hollow cone. Any hollow cone you get and you have to use calculus, you have to take the distance from the apex along the conical surface. Okay, please take a screenshot of this. So this completes our study of center of mass, finding the center of mass. In the next class, we'll see how to define the velocity, the acceleration of center of mass, and therefore we will write down Newton's second law for a system of objects. Okay. चलो ठीक है, फिर I will see you. हाँ, बस वही first 10 क्वेश्चन कर लो अभी.